Okay, we are on blood now. So this is the first in a three-part series, which is the cardiovascular system. So the cardiovascular system, the next three chapters, is going to consist of blood, the heart, and then the vessels that the blood's in. So we're going to start off with blood. A little bit easier chapter after the endocrine system. So let's talk about some of the characteristics of blood. So as you see on this slide is pretty good at exemplifying the characteristics of blood. You see blood is about 55% plasma and 45% what we call formed elements. So the plasma is the liquid. It's essentially water. And then the formed elements are red blood cells, white blood cells, and platelets. And red blood cells really dominate the formed elements. So you see that formed elements are about 45%, and plasma, the liquid that the cells float in, that's about 55%. So one of the lab readings is hematocrit. So figure out how much of the blood is made of formed elements. So your hematocrit should be somewhere around 45. So for men, maybe a little bit more, 47. For women, a little bit less, 43, something like that. But in that range. So you would imagine somebody that would be dehydrated would have less plasma, because as you see, like look at the slide, you see plasma, and most of plasma, about 92%, 91% is water. So if you have less water in your body, you're dehydrated, you're going to have less plasma, right? So if you're going to have less plasma, now the percentage of plasma versus formed elements shifts, and so you're going to have a hematocrit much higher than you would expect. So let's look at both of these. Let's look at plasma first. If you look over to the next part, plasma is made of mostly water, and then about 7% plasma proteins. And in fact, the three plasma proteins are listed on here. Now, the three main plasma proteins: albumin, globulin, and fibrinogen, right? And then there are some, of course, there's other things in plasma. You're going to find some carbon dioxide in plasma a little bit, and some electrolytes. But mostly we're talking about water and plasma proteins. So let's look at the three plasma proteins that were listed on that previous slide. And there you go, fibrinogen. We're going to talk about fibrinogen again because they're involved in clotting. And if you remember anything from the last lecture, when a word ends with OGEN, that's an inactive enzyme. And what's the active enzyme called? You just take off the OGEN. So fibrinogen is involved in clotting. Fibrin, that's actually what's going to make the clot. So anyway, fibrinogen is one of the plasma proteins. Globulins, those become what are called immunoglobulins once we talk about the immune system. That's coming up in a few chapters. And then albumin. So albumin, I put here, used to transport. It has a few jobs, albumin. But with transport, we're talking about transporting fluids. So how do fluids move into capillaries and out of capillaries? How do we get water or fluid in our blood vessels and out of our blood vessels? Using albumin is one way. So albumin is a solute. Just like water is attracted to sodium, water is also attracted to albumin. But we'll talk about that. So for this slide, I definitely want you to know it. It's definitely something that I might ask on a test. What are the three plasma proteins, and what do they do? And so this slide would take care of that. So some other things about blood, the pH of blood is about it's 7.4, right? There's very little variance that your blood has. So 7.35 to 7.45. So you could have a blood pH that is 7.3, and we would call that acidic. And then somebody might think, well, no, 7 is like the neutral. So if you remember pH, it goes from like 1 or 0 to 14, and 7 is neutral. And then we call things above 7 basic, and we call things below 7 acidic, right? So here we are with blood. It's not 7.4, it's 7.3, but we're calling it acidic, right? And it's, so you're in this case, neutral is not 7, we're using 7.4. So it went below 7.35. If your blood were 7.3, we would call it acidic, 7.25. It doesn't, there's not a lot of room that, there's not a lot of variance for that pH. And then 7.5 would be alkalosis, anyway, the pH of blood, it's got that range, 7.35 to 7.45. Your body is set up to keep it in that range. You have about 4 to 5 liters of blood in your body, right? And so remember, everything is going to be on liters. And so just as we actually haven't talked about it, but you should know that a liter is, well, a 2-liter bottle of Coke, and they sell them in 1 liter, so you can go see what a liter looks like. And then a standard water bottle is 500 milliliters, which is half of a liter, right? So there's 1,000 milliliters in 1 liter. So the water bottle is a good approximation of 500 mils or half a liter. So you have 4 to 5 liters of blood in your body. It changes throughout the day, and it depends on a lot of things, how tall you are, and it depends on gender, right? So men are going to have a little bit more, and women are going to have a little bit less, but it's somewhere within 4 to 5 liters. So the temperature of blood, not like a really major important thing, but it's about 38 degrees. Your body temperature on average is about somewhere around 37 degrees. So it's a little bit warmer than your body temperature. So that's it. That's a real general introduction to blood. I'm going to stop here. I'm going to make another lecture on just red blood cells, and then I'll do one on white blood cells and platelets. So I'll stop here.